Great! Now that we have the basics out of the way, let's start working on the prototype. First, we need to create a new project folder. You can name it whatever you like. Now, open it with VS Code by navigating to File, then Open Folder, and select your new folder. Great! Now, we're ready to begin. Since we already have the Streamlit package prepared, we'll only need to install OpenAI. We do this by opening a new terminal and writing the following command: pip install OpenAI. Next, we must create a new folder called .streamlit in our project directory. This folder will hold configuration files for Streamlit. We now need to create a new file in this folder called secrets.toml. In this file, we'll store our OpenAI API key. Inside the secrets file, we enter the following line: open API key equals to double quotation marks. We'll paste our API key here. To do that, we first need to generate a new API key. So, go to your OpenAI profile. Navigate to View API Keys under the API section. Click on Create New Secret Key and give it a name of your choice. Then click Create Secret Key to generate it. Copy and store your API key in a secure place. After this step, you won't be able to view it again. Once you have your API key, go back to VS Code and paste it between the quotation marks in the secrets file. For the next step, we need to return to the main directory and create a new file called app.py. We'll write our code here. We'll begin by importing the Streamlit library and the OpenAI class from the library of the same name. Here's how you do it. Now, let's set up the configuration for our Streamlit page. Use Streamlit's setPageConfiguration method to set the page title to Streamlit Chat and the page icon to a chat emoji. Next, let's set the title of our app to Chatbot. Let's run the code to ensure our app runs well without any problems. For now, we should only see the title. Returning to the source code, let's initialize the OpenAI client using the API key stored securely in Streamlit's secrets management. So, we add the following line to do this. This line creates an instance of the OpenAI class. The API key argument securely pulls the API key from Streamlit's secrets file, ensuring it's not exposed in the code. Alright, we've now set up the client to interact with OpenAI's API. Next, we'll set up our model by creating a session state. First, we check if the session state already contains a variable for the model. So, we write, if OpenAI model not in st.sessionState. If the session state doesn't contain the OpenAI model variable, we create one and assign it to the value GPT-4o. We can do this by writing st.sessionState square brackets OpenAI model equals to GPT-4o. If we want to use a different OpenAI model, we change the name in the last string. It's important to note that you must provide the exact name of the model as specified in OpenAI's documentation. Otherwise, it would result in an error. In the next lesson, we'll take this setup to the next level by creating a fully functional chat application. Stay tuned! Welcome back! Now that we've set up our libraries and API key, we can start working on the logic. First, we must initialize the chat history and check if a key, which we'll call messages, already exists in the session state. The messages key stores the entire history of our chat, including all messages sent by the user and the assistant. It acts as a container that keeps track of the conversation as it evolves. If messages is not a key in the session state dictionary, it means that we haven't started storing any messages yet. In this case, we initialize it by setting session state.messages to an empty list. Alright, Let's create the chat. First, we start with an input field for the user to type their message. The chat input method creates an input box with a placeholder text reading your answer. When the user submits a message, it's stored in the prompt variable. The syntax if prompt : equals is a compact way to assign the value to the prompt object and check if the input is not empty. Once we have the user's input, we append it to our session state that we called messages, with the role being user and the content being the user's input. Then, we display the user's message in the chat interface using the chat message function to create a message block. Next, we use the markdown function to render the message content. Now, we prepare to get the chatbot's response. We create another chat message block for the assistant's response and call the OpenAI API to generate the response. We do that with this code. We first use the with statement to create a context block. This is followed by the chat message method, in which we pass the string assistant as an argument. This creates a dedicated block to display the assistant's response in the chat interface. Next, we call the OpenAI API to generate the assistant's response. The OpenAI's create function used here takes several parameters. The first is model, which specifies the model we're using, which we defined earlier as GPT-4o. Messages is the parameter that takes the entire chat history as the context for the assistant's response. To provide this chat history, we loop through the messages list in the session state using a list comprehension. List comprehension is a concise way to create a new list by iterating over an existing one. In this case, it takes each message in the messages list, extracts its role and content, and reformats it as a dictionary. This structure gives the assistant all the necessary context for generating a meaningful reply. Each message is represented as a dictionary with two keys: role, which indicates who sends the message, and content, the actual message. Finally, we set the stream parameter to true to receive the response as a stream, which allows for more user-friendly interaction. This would then allow us to use the writeStream method we discussed in a previous lesson, displaying the response in a dynamic and visually appealing way. We captured the response in a variable named accordingly, and we append it to the messages list. We've made good progress. Let's save the code, refresh the page, and greet our chatbot. Amazing, we have a response. But notice that we can't view the entire chat history on screen. Instead, we get only one box for the user's message and one for the assistant's response. The messages are still saved in the chat message list in the session state, but we can't see them. The application displays only the last user message and the last assistant response. Our next task is to display the chat messages in our Streamlit application. Here's how we do this. Let's break it down. The loop goes over each message in the session state messages. If the role of the message is not system, we create a chat message block that can take one of two roles: assistant or user. Using the markdown function, we put the content of the message. So, the code goes through all the messages and displays them. Note that we do not include system messages since we don't want the users to see our prompt. Save the code, refresh the page, and let's test it to see if it works with a couple of inputs. First, I'll type, "Hello, how are you doing?" And we have a response. I'll add another input. "Tell me a fun fact." And again, the assistant responds dynamically with a fun fact. Great. We now have a ChatGPT-like chatbot. Let's review one more point before we wrap up the lesson. To include a system message where we write our prompt, we just need to append an additional element to the messages list. So, we go to the top of the code, where we initialize the messages session state and modify the line like this. In this code, we add a role to the message, setting it to system and adding the prompt. "You are a helpful tool that talks like a pirate." Go ahead and save the file, then run the code. Now, let's ask our chatbot to tell a joke and see how it responds. Wow, what a response! We now have a ChatGPT clone that speaks like a true pirate. Great! In the next lesson, we'll set up a configuration stage for our prototype. See you there. Now that we have our simple chatbot up and running, let's enhance it by adding a setup. This will allow the user to input personal information, which we can use to personalize the chat experience. In the setup, the user should be able to write their name, experience, and skills, and select from given options for level, position, and company. Let's start by adding a subheader to indicate where the personal information should be added. We do this by writing st.subheader. We'll label it as personal information. To make it more visually pleasing, we can add a divider at the end. To do that, write divider equals to rainbow. Save the changes in VS Code and switch to the browser. It looks good. To add a text box for the user's name, we write the following line. Let's break down what this line of code does. The label parameter sets the label of the text input field to name. The max characters parameter limits the number of characters the user can enter. For now, we will set it to none, which means there is no limit. And the placeholder parameter displays a hint within the input field, asking the user to enter their name. Let's save the application and check our UI in the browser. And we see our text box on the screen. Next, we must create input fields for the user's experience and skills. Since these fields require more space for longer entries, we'll use text areas instead of text inputs. Here's how we can set them up. These text areas function similarly to the name input field but offer a larger space. The value parameter sets the default value of the input field, which we'll leave as an empty string. Great. Now, let's run the app. Nice! We have our text boxes in place, but we're not sure if they work as expected. Let's create a label to display the user's input and confirm that the text boxes function correctly. We'll use the write method and an f string as an argument to format our message. Each variable, name, experience, and skills, is placed inside curly braces, which tells Python to substitute those placeholders with the actual values provided by the user. We can also add 2 asterisks at the beginning and the end of our text to make our labels bold. Let's test it. For the name field, we'll type Alex. For experience, let's enter 2 years as a data scientist. And for skill, we'll add Python. And it works! Next, we need to add the fields for company and position separately. To start, let's add another subheader. And again, we can add our signature divider. To enhance the user interface, let's organize our layout into 2 columns. To do this, we index them as 1 and 2 and use the columns function to specify the number of columns we want. In our case, we'll create 2. In the first one, we'll add radio buttons for the position level, junior, mid, or senior. We'll use a with statement to access it and define its radio button logic within it. Here's how it looks. In this setup, the level variable will store the selected option. We call the radio function to initialize the radio buttons. Inside this function, the first parameter, choose level, is a label displayed above the options to prompt the user. Next, we use the key parameter and set it to visibility, which can help maintain the widget's state across interactions. Finally, the options parameter provides the list of choices available for selection: junior, mid-level, or senior. For the position selector, let's create a drop-down menu in the second column. Once again, we'll use a with statement to access the second column. This time, we'll assign the selected position to the variable position using the selectBox function. Now, we'll define more choices. This will allow users to select their position from a predefined list of options. These are data scientist, data engineer, ML engineer, BI analyst, and financial analyst. Finally, let's add another drop-down menu to select a company. This time, we won't place it inside a column. Once again, we'll use the selectBox function and enter a few company names as options. Let's go with Amazon, Meta, Udemy, 365 Company, Nestle, LinkedIn, and Spotify. Looks great. Let's test if it works once more by displaying the selected values with the label. Great! Now that we have the setup, let's connect it to the chatbot. Head back to the code where we initialized the system message, also known as the prompt. Remember the prompt template we defined and tested a couple of lessons back? We can replace the existing system message with that template here. Good job. Let's test the application. First, save the file and refresh the page. The complete layout looks great. Now, let's test the setup by entering some dummy data. Again, our name will be Alex. We have 2 years of experience, and our skills include SQL and Python. We'll select Senior, Financial Analyst, and the company Spotify. The setup appears to work as expected because the labels display all the variables we've defined. Now, let's test the chat by asking, "What is my name?" Unfortunately, the chat doesn't know our name, so the setup information hasn't been passed to the system message. The model has no knowledge about our setup. This is because the user inputs for name, experience, skills, level, position, and company are not dynamically updated or incorporated into the session state after they're initially set. In other words, while they're captured and displayed in the setup stage, they're not actively passed to the session state or the chatbot during the conversation. Therefore, we must store the user's input in the session state and update it dynamically. We'll do this in the next lesson. In the previous lesson, we set up a basic chatbot and a page that collects user information. But we encountered an issue where the chatbot did not recognize the information provided during the setup stage. In this lesson, we'll address this problem and enhance our chatbot to ensure it effectively utilizes user input. So, first, let's think about how we can solve this. We need to track whether the setup for the interview is complete. To do this, we can initialize a session state for the setup stage. We'll name it Setup Complete and initially set its value to false. This time, instead of directly changing the session state within a button, we'll create a cleaner version by defining a function to toggle the setup phase completion. Later, we'll attach this function to the button using an onClick event. This is an additional parameter that lets us specify a function that runs when the button is clicked. This allows us to trigger action, like updating the state, in a clear, organized way. Now, we must show the setup form only if the setup is incomplete. We do that by wrapping the whole setup form in an if statement that looks like this. This line checks if the setup complete session state variable is false. If it is, the form will be displayed, allowing the user to input their details. Once the setup is complete, and setup complete is set to true, the form will no longer be shown. Next, we must initialize session state variables for the user's personal information. This will allow us to keep track of the user's inputs across interactions and ensure the data is persistent throughout the session. Here's how we do that. For each piece of personal information, name, experience, and skills, we first check if a corresponding key exists in the session state. If the key does not exist, the session state for that variable hasn't been initialized. In this case, we create the key and set its default value to an empty string. Now that we have our variables, we'll update the personal information input fields to save their values directly into the session state, making the data available across interactions. We add st_session_state, followed by a set of square brackets, and pass the variable's name as a string. The same steps for the company and position information. First, we initialize session state variables for each input. And notice how we ensure each variable has a default value selected when the user starts the interview. This gives a starting point for each dropdown or selection input. Next, we again need to update the input fields to pull from the session state. In the previous version of the code, the selected values for level, position, and company were stored in regular variables. Now, we're integrating these fields with the session states we've just created. We rewrite the variables by adding st.sessionState, square brackets, and the name of the variable. We also set the index parameter to the session state. We apply this change to all variables to fully integrate the input fields with the session state. And finally, we need to add the button to complete the setup phase and trigger the session state update. Remember the onClick parameter that we mentioned earlier? It will call the complete setup function. This button will turn the setup complete session state to true, causing the setup form to disappear. This ensures the user completes the setup phase before moving on to the interview phase. We handled the transition similarly by checking if the setup complete session state is set to true. We then wrap our chatbot code inside this if statement. Now, let's move on to our chatbot. One thing we can do to make it more engaging is by adding an info box to guide the user, providing a friendly prompt to start the conversation. To do this, we'll introduce a new function, the info function. Here's how we use it. We write st.info, then the message we want to display. In our case, it will be, start by introducing yourself. We can also place an icon parameter, which allows us to add a visual element, such as an emoji. Before we wrap up this lesson, one last step is to connect the session state variables with the prompt. This ensures the chatbot can access the information collected in the setup phase. We achieve this by passing the session state variables into the prompt message. To reference a session state variable, we use the syntax st.sessionState, square brackets, followed by the variable name. This approach dynamically inserts the user-provided data into the prompt message. Let's test the interview to make sure everything works as intended. We'll start by filling out the setup fields with dummy data. For the name, let's enter Alex. In the experience field, we'll type 2 years of experience as a junior data scientist at Global Nets. Then, we'll complete the level, company, and position information. Once that's done, we click on Start Interview. Now, let's begin with a simple introduction. As you can see, the model recognizes our name and even remarks on our background, just like an actual interview. Great job, everyone! In the next lesson, we'll take the app to the next level by adding a feedback feature and making overall improvements to the project. See you then! Now that we have the working setup and chat, we can start creating the post-interview feedback. We'll work on building better session management. Right now, our application doesn't track the number of messages exchanged, so the interview could go on infinitely, or at least until we run out of tokens in our account. To manage this, we'll initialize a session state variable to keep track of the user's messages. We'll call it userMessageCount and set its default value to 0. We might also need a session state similar to the one for the setup complete that indicates whether the user has been shown feedback for the interview. Initially, it should be set to false, but change once the feedback is generated and shown. To keep all session state variables organized in one place, we can move the initialization of the message state to the top. It will store the conversation history, including all messages sent by the user and the assistant. This way, we ensure we have a place to store and access all the interactions, and seamlessly manage and reference the conversation history across all stages of the chatbot's flow. Next, we need another session state similar to the one that tracks the completion of the setup stage, which will track the completion of the interview. We'll call it chat complete, and, once again, set its default value to false. Great! Now, we have our system for controlling the application's flow to ensure a smooth transition between the different stages: setup, interview, and feedback. We already have a function that toggles the completion of the setup phase. Now, let's add another function to toggle the feedback display. We'll name it show feedback. When it's called, it will set the feedback shown session state to true. Before we wrap up this lesson, here's an important note. We should always impose word or character limits on any input field that goes into the LLM. This ensures that the model doesn't receive excessively long inputs, which can lead to inefficient processing and potential issues. For the name input field, 40 characters should be enough, so we can add the following. For the skills and experience, we can set, let's say, 200 characters. Great! On to the next lecture, where we'll implement the feedback functionality. Alright, now we need to work on the feedback part of the interview. Let's start off by modifying the code that shows the interview chat. Previously, the code only checked if the setup phase was complete to display the interview interface. We can change the if statement like this. In this statement, we check 3 conditions to determine the next phase of the application flow. 1. We verify that the setup phase is complete. 2. We check if the feedback hasn't been shown yet. 3. And finally, we confirm that the interview is not yet complete. By combining these 3 conditions using the logical AND operator, we are determining if the application should proceed to the interview phase. The next step we need to take is to change the initialization of the session state for OpenAI. Since we already initialized messages as an empty list, we can check if it's still empty. If yes, we set the initial system message. This ensures that the chatbot starts with the correct context. The if not statement checks if the messages list is empty. This might initially seem counterintuitive, but it's because an empty list evaluates to false in a Boolean context. So, when the list is empty, not false turns true, allowing the code block to run and initialize the system message. Alright, let's now work on managing the user message count so that the interview stops after a certain number of responses. Before the code accepts the user input, we check if the user has sent fewer than 5 messages. We do that with an if statement. We place our code for handling user input inside this if statement, which ensures the input is only accepted if the user message count is below 5. Here, we can set a character limit for the user's input field to prevent excessively long responses. This helps optimize token usage and reduces unnecessary costs. We also need to wrap the code that generates the assistant's response with an if statement, like this, to ensure the chatbot stops responding after a specific number of user messages. This condition checks if the user has sent fewer than 4 messages so far. If the statement is true, the assistant's response will be generated and displayed. If there are more than 4, the assistant won't respond, ensuring we limit the interaction to a maximum of 5 user-assisted interactions. Next, we add this line after the previous code to increment the user message count by 1 every time the user sends a message. This keeps track of the total number of messages the user has sent. After incrementing the message count, we check if the user has sent 5 messages. If the count reaches 5, we set chat complete to true, indicating that the interview is complete and preventing further input. So now, let's test the application. save, and run the application in the browser. For the setup stage, we'll add some dummy data to the input fields and click Start Interview to move on to the chat phase. Now, we can type and submit responses to interact with the model. Let's quickly answer the questions. But now, you'll notice that the model stops responding once the message limit is reached. Great work! In this lesson, we refine the chat functionality by adding message limits, ensuring structured interactions, and seamlessly managing transitions between the setup, chat, and feedback phases. Welcome back! Let's continue with our development. The next task on our list is to implement the feedback feature. To start, we need a button that, when clicked, will display the feedback. Here's how we can achieve that. First, we must ensure that the button is displayed only after the chat is complete and the feedback has not yet been shown. We do this with an if statement, where the first part checks if the interview has reached its message limit and is marked as complete. In the second part, we use the not operator to confirm that the feedback has not already been displayed. Together, these conditions control when the Get Feedback button appears. When the button is clicked, it triggers the Show Feedback function that we created earlier. This function sets both the feedback button clicked and the feedback shown to true. We'll add a line after the button is clicked to let the users know that the feedback generation process has started. Next, we create the feedback screen. We start by checking if feedback shown is true. If it is, we display a new section with a subheader titled Feedback. In this if statement, we create a new variable called Conversation History that joins all session state messages from the session state messages list into a single string. Each message is formatted to show the role, user or assistant, and the content of the message, separated by a new line character, represented by /n. Now, we need to set up another model to serve as our evaluator, following the same steps. We initialize a new OpenAI client instance. Notice that we reference the same API key stored in the secrets file. And again, we add our model name and messages. First, we have our system message. Here, we'll tell the LLM that it's a helpful tool that provides feedback on an interviewee's performance. We'll also specify the format we need, detailed feedback, and an overall score from 1 to 10. Additionally, we'll include specific instructions to ensure the model gives only feedback and doesn't continue the conversation because models sometimes hallucinate and add unnecessary information. We can add a user message where we pass the chat history and says, "This is the interview you need to evaluate. You are only a tool and shouldn't engage in conversation." This ensures that the LLM focuses solely on providing feedback and does not continue interacting with the user. Next, we extract the first message generated by the new model with the following line of code. This step is necessary because the output of the feedback completion function is a structured object containing a list of potential responses, which are referred to as choices. It would look something like this. Each item in the choices list represents a possible reply from the model and includes details such as our well-known roles. So, with this code, we ensure that we extract the first message from the list, which is the feedback. Let's test our application again. Let's skip ahead to the most exciting part. I've already completed the interview, and now I'm posting the final answer to wrap things up and finalize the interview process. Now, at the end of the interview, we should see a Get Feedback button. When you click it, the application processes the chat history and generates feedback. After the application loads, you'll see an overall score out of 10, followed by detailed feedback, formatted as we specified in the prompt. Alright, this looks nice. Another enhancement we can add is navigation back to the setup page, allowing users to start the interview process over again. There's a clever way of doing this with the following code. We first install the library called Streamlit JS eval. This library allows us to execute JavaScript commands directly from Streamlit, enabling advanced functionality like refreshing the page or interacting with the browser. Then, go to the beginning of our file and import the necessary function. We can then add the following code to the feedback page. This way, we restart the interview by refreshing the page, providing a seamless experience for users to begin a new interview session. Let's test the application one final time. For this demonstration, we've skipped ahead to the last question of the interview. Once we press the Get Feedback button, we see the feedback generated by the model displayed on the screen. Now, notice that we also have a new button labeled Restart Interview. When we click it, the page refreshes, and we are seamlessly brought back to the setup stage, ready to start a new session. The next step is to remove the text labels we use to test if the text boxes recorded information. Great! Looks cleaner now. Well done, everyone. With this, our application is fully functional and complete. But if you pay close attention to the interview and the feedback output from the large language model, you'll notice that sometimes the responses lack depth, offer generic insights, or fail to provide well-structured feedback. For your homework, I suggest you work on prompt engineering to create better prompts for both the feedback and the interview. Additionally, experiment with tweaking the settings of the model to achieve better results. For instance, you could revisit the scoring system mentioned earlier in the course or implement a question-by-question evaluation. Try adjusting parameters like temperature or top p-values to observe how they affect the feedback quality. Feel free to build on this project. You can improve the design or even change the topic altogether. For example, you could create a debate simulator where, on the setup page, you decide the topic of the debate and the difficulty level. The interview screen would then turn into a debate screen. Instead of feedback, the second model would decide who wins the debate. Alright, in the remaining lectures of this section, we'll cover how to upload our code to GitHub and host our application via Streamlit services. See you there! Welcome back! Now that our project is nearly complete, it's time to upload it to GitHub. As you are probably already familiar, GitHub is the most popular platform for version control and collaboration, and it will help us manage our project and deploy it using Streamlit. In this lesson, we'll walk you through the steps to upload your project and explain how to commit any changes you make. But before we start, it's essential to note that you should never upload your API keys to GitHub. Automated bots called crawlers scan public repositories for sensitive information like API keys. If these keys are exposed, unauthorized users can exploit them, potentially draining your funds. Always ensure your sensitive information is kept secure. First, we must create a repository on GitHub to store our project. If you don't have a GitHub account, the first step is to sign up for one at github.com. Once you've created your account and have signed in, the next step is to create a new repository. Begin by clicking on the New button located on the top right corner of the GitHub homepage, or navigate to the Repositories tab and click New. Next, we need to choose a name for the repository. I'll go with Interview-Tool. Now, we must decide whether it will be public or private. If we choose public, anyone can view our repository, whereas private means only those you select can see the repository. For this project, we'll choose public, and I'll explain the reasoning behind this choice in the following lesson, where we discuss deploying the app. After making your selection, click on Create Repository. Now, don't close this window. Go back to your project in VS Code and open a terminal. In the terminal, we need to initialize a local Git repository and connect it to the GitHub repository we just created. Start by navigating to your project directory if you're not already there. You can do this using the cd command followed by the path to your project folder. Once in the project directory, initialize the Git repository by running the command git init. Next, add all your project files to the staging area using the command git add dot. Now, commit these files with a message describing this as the initial commit. Like this, git commit -m. And we add a message with the text initial commit. You might be asked for verification, so follow the steps written in the terminal. Before we proceed, let's quickly discuss branches. Branches in Git allow you to work on different project versions simultaneously. The default branch is where your main development happens, and it's common practice to name it main. After committing your files, rename the default branch to main using the command git branch -m main. This ensures that the primary branch of your repository is named main. The next step is to connect your local repository to the GitHub repository. To do this, we must return to the GitHub page where we created the repository. We then need to copy the remote repository URL. After that, go back to the console and write git remote add origin and add your URL address. This command tells Git where to push your project files on GitHub. Finally, push your local repository to GitHub using the command git push -u origin main. This command uploads your local repository to GitHub and sets the remote repository as the default for future pushes. Follow the instructions if you're prompted with a message asking you to sign in. Now, return to your GitHub repository page and refresh it. You should see all your project files uploaded. Congratulations! Your project has now been successfully uploaded to GitHub. If you make any changes to your project files, you need to update your GitHub repository to reflect those changes. Here's how you can do that. First, we add the changes to the staging area by again writing git add all. We commit the changes with git commit and write a descriptive message, such as updated the prompt, and we again push it to GitHub. Great! In the next lesson, we'll take it a step further by deploying our application using Streamlit services. This will allow us to share our interactive app with others quickly and efficiently. See you there. Now that your project is uploaded to GitHub, it's time to make it accessible to others by deploying it. In this lesson, we'll walk you through the process using Streamlit Community Cloud. Streamlit Community Cloud is a fantastic service that allows you to host and share your Streamlit apps with just a few clicks, making it incredibly easy to showcase your projects to the world. Plus, it's free. But there's a catch. You can only host Streamlit apps that are public on GitHub. This means that everyone will be able to see the source code of your application. While this might seem like a drawback, it also allows others to learn from your work and contributes to the open source community, a worthwhile trade-off. First, we need to create a requirements.txt file. This file lists all the dependencies required to run your Streamlit app. This ensures the Streamlit Cloud knows which packages it needs to install to run your app smoothly. To create this file, open a text editor and create a new file named requirements.txt. Now, we need to add the libraries we've used. For our project, the requirements file should include Streamlit, OpenAI, and Streamlit.js eval. It's as simple as that. But what if you have so many libraries that you can't track them all, and you encounter errors every time you try to run the app on the server? In such cases, you can use the following command in the VS Code terminal to generate the requirements file automatically. This command will create a requirements file containing all the packages and dependencies currently installed in your environment. Once we have this file, we must commit and push it to GitHub. We start by writing in the terminal git add dot to add all the files. Then, with git commit -m, we can write a commit message. For example, adding the requirements file. Finally, push the changes to the remote repository. Git push origin main. Alright, to deploy the app, we first need to visit share.streamlit.io and sign in with GitHub and set up your account. Once signed in, click Create App and select Deploy a public app from GitHub. You'll be presented with a form where you need to add information about your repository. In the repository field, add the link to your GitHub repository. We've used main for the branch, so select that. The main file path should point to the file you use to run the app, which in our case is app.py. If needed, you can also customize the app URL. Next, click on the Advanced Settings button. This is where we can add the content of our secrets file. Paste your API key here in the following format. Save the changes and click Deploy. After a few seconds, your app will be deployed. Let's test the application to ensure everything works perfectly. And it does flawlessly. Now, we have an app that's up and running. You can share the link with your friends to try it out. We did it! Congratulations on deploying your first LLM app. In the next section, you'll get an inside look at how we built the ACE interview, our interview simulator that is up and running today, helping thousands of students prepare for their job interviews. So stay tuned.